So Chapter 2, Section 2.1 is on linear functions, and we'll also look at quadratic functions and modeling. So the first part is just going to be dealing with polynomial functions, and then specifically we'll look at linear functions, so equations of lines. So the first thing we'll look at is what a polynomial function is. Polynomial function, the exponent for your variable there has to be a non-negative integer, so the exponent, and it also can't be a negative, and it can't be a fraction. You can't have a fractional exponent. And then all the other coefficients for your x terms will all be real numbers, and this lead coefficient here will not equal 0 there. So if you look at these examples here, which ones are polynomial functions? What's the degree? What's the leading coefficient? So if you look at this, the highest power for x is x squared, so it is a polynomial. That's a non-negative integer for that degree, so a degree is 2. And the lead coefficient is the coefficient of that term, which is square root of 2. If you look at the next one here, this one's not a polynomial because that exponent for your x there is a negative value. For this one's also not a polynomial because you have that square root function. That whole thing is underneath that square root, so it's not a polynomial. And for this last one here, this is a polynomial. The degrees for, or the variables have an exponent that's positive, and that is not a fractional exponent. So it's a polynomial. And the degree for that polynomial would be 5. And its lead coefficient, don't forget the negative, it's a negative 4 for that one. So they'll ask you some things about polynomial functions. Are they polynomials? Are they not polynomials? And then this one tells you about the degree for polynomials. We'll deal with quadratic polynomials there where you have degree 2. A linear is degree 1. We've dealt with those things. Constant function, that's just y equals a number. It's not 0, so like maybe y equals 5, f of x equals 5. The degree for that would be degree 0. If you want to think of that as having an x with it, it would be x to the 0 power, which is 1. And then y equals 0, which is just the x-axis. They say that for that one, the degree is undefined. Just sort of differentiate between these two situations here. All right, so let's look specifically at linear functions. And a lot of this stuff is all review in this part of it where we have slope of the line, change in y over change in x, rate of change. We talked a little bit about that as the slope of the line represents the rate that something is changing there. Slope-intercept form, point slope form, standard form, the three forms for the equations of a line. And typically, if they don't tell you how they want the equation written, you can write it in any of those forms there. If they say, like they do for this example one, they want it as a linear function, they want you to write it as f of x equals. So we'll go back and we'll write it in that form there. So they give us 2 points. It doesn't really look like they're points, but that's what these two things are here. When x is 3, y is negative 5. And when x is 6, y is 2. And we can take those 2 points and we can find a slope. So that would be negative 5 minus 2 over 3 minus 6 going in the same order. Subtract it from the top point minus the bottom point. This is negative 7 over negative 3, which is 7/3. So that's my slope. And then I'm going to pick one of these 2 lines or 2 points to work with. And it seems most of you like this form. You can use y equals mx plus b. If I pick, I don't know, I'll pick 6, 2 since both of those values are positive. I'm going to plug in for x and for y the coordinates of the point. And for my m, it's my slope, so I'll plug in my slope value there. And I can solve for the y-intercept then. So this is going to be 2 minus, that's going to be, 214. And if I subtract, I get a b value of negative 12. And then if I take that and write that in y equals mx plus b form, I'll have y equals the slope, which was 7/3, x minus the y-intercept, negative 12. So write a linear equation. You'll see a few that are like that. You may see some that are set up as word problems, which is this third example here. So they give us actually a couple of points. You may not realize that that's what they actually are. So they say you purchase a car for $30,000. After 5 years, the car's value is $12,000. Write an equation for the depreciation of the car's value. If it depreciates linearly, what's the rate of depreciation, and then what does the y-intercept represent in the problem? So we're really given points in terms of time, and I'm going to say v for value. So my car is originally worth $30,000, and that's really when time is 0. That's the time that you purchase it. And then after 5 years, so when time is 5, now the car is only worth $12,000. So we're going to write an equation for that. So the slope then would be the change in the value divided by the change in the time. So 30,000 minus 12,000. Oops. And then we start with 30,000, so we'll start with 0 minus 5. And if you subtract and you divide there, we get a value of negative 3,600 for our slope. And that's the rate that the value of the car is decreasing there. That's why it's a negative value there. And it says write the equation. So if you want y equals mx plus b again, we can do that. Pick one of your 2 points. I would probably pick this first one. You're going to see you actually already have the y-intercept. So 30,000 equals the slope of negative 3,600 times your x value, which is 0 plus b. So here's my y-intercept. And then the equation in the line would be y equals negative 3,600 x plus that b value. Or if we want to write this in terms of v's and t's, negative 3,600 t plus 30,000. All right, just using the variables that we started with. And then what's the rate for depreciation? We talked about that. That was the slope. And then what does the y-intercept represent? Oops, if I can spell it, represents, that's the 30,000. That's the initial value of the car. Right, so the value of the car when time is 0. So you'll see a few problems like that, and that's basically it. You have to kind of pull the points out of the problem there. Right, the last thing we're going to look at is the correlations in modeling. So we'll go through and I'll show you how to do this with your calculator. So you will need a graphing calculator. If you need to borrow one from my, my little card over there, grab one. If you have a set of data points that you've collected, you may have a linear relationship or a linear association with them. It just means that the points are kind of in the shape of a line as opposed to maybe a parabola or a sine curve. If it's a positive linear association or a positive correlation, what they're looking at is the points will go up from left to right. These kind of go up from left to right there. A negative association, a negative linear association, points are going down from left to right. So if you kind of put a bubble around your points there, you can kind of see the direction that that bubble is headed. If you look at these correlations, these first two are strong correlations. The more that little bubble looks like, I don't know, like a pencil, you know, sort of long and thin there, a piece of spaghetti, if you want to think of it like that, you have a strong correlation. The more it starts to look circular like you have in this one, the less correlation you have. It means that, you know, the two things that you're looking at really, you know, maybe one doesn't really affect the other one. So, you know, it's sort of in general terms like that, in terms of their correlations. All right, your calculator will give you this correlation coefficient for lines, this R value. Only linear models. This Pearson product moment, and we'll talk about that as we go through and we do other types of correlations. R squared, it takes that R value and it sort of disregards whether it's positive or negative. And what it tells you how strong the correlation is by looking at a percent. So if we go back up here, this R value will fall between -1 and +1. The closer that value is to 1, the stronger the correlation. So if you end up with an R value of 1, that means it's a perfect correlation. It means that all of those points that you've collected from your data are all on the same line. You could have a positive correlation or negative correlation depending on whether R is positive or R is negative. And then the closer R is to 0, you're going to have either a weak or no linear association at all. So you want that R value to be close to 1. If we take that same R value and you square it, you're going to get, some kind of decimal that's less than or equal to 1. So if you get an R squared value of 0.99, if you convert that to a percent, it'll give you 99%. And what that means is 99% of the Y value can be directly attributed to the X value. So if you think of, here's an example for you, that previous one there. This was time, and this was the value of the car. Right, so if we had plotted those points, whatever they happen to look like, if you get a big R squared value, suppose we came up with an R squared value of 0.99, it means 99% of the value of the car can be attributed, to the time that you've owned the car. So it talks about that. Maybe it's something else that's affecting the value of the car. If you smash up the car, it's not going to have the same value as if it's not been smashed up. So what we're going to do, take your calculator out. We're going to start setting your calculator up to do scatter plots. So when you, the first thing you want to do is we're going to turn that R squared and that R value on your calculator. And as long as you don't take the batteries out of your calculator or reset the memory, it'll stay like this. The default turns it back off. So you're going to hit the blue second button and then the catalog button, which is the number 0. All right. And when you do that, you'll see over in this corner here next to the battery side there, you'll see an A. That means your alpha lock is on. And what that lets you do is in green you can see the letters of the alphabet. We want to go to the diagnostic test. So that's in D, which is the x to the -1 key. And that brings you to the beginning of the D's of the calculator. So we're going to scroll down, and my calculator takes a little while to do this. It's not as fast as real life is. You're going down to diagnostic on. There it is. So diagnostic on, you'll hit enter, and then you'll hit enter again. It should tell you that it's done. It just means that it's turned this functionality on into your calculator there. All right, so you can clear that out. So now when we go in and type things in, you should see this R value. All right, so we're going to set up your calculator to do this next example. So let's look at the example first, and then we'll go back and pull the calculator up. So we have a car, little toy car that is traveling in seconds, and we're going to measure the distance it travels over different time intervals there. So that's the data that we're looking at there. So we're going to go through with the calculator. I think you can probably go through and sketch a scatter plot by hand, but we're going to go through and set the calculator up to do this. So if you pull up your calculator, we're going to go in and we're going to set this up so we can create a scatter plot. So hit the second key, which is blue, and the Y equals button. And this will turn the scatter plot on in your calculator. So we're going to go into plot 1. Just hit enter. We want to turn it on. See how the cursor's flashing on off. Now it's flashing on on, so it's locked on. We do want this first graph, which is a scatter plot. And you should have list 1 and list 2 for your X and your Y list. If not, suppose you had, I don't know, list 3 in there. And you don't want that. You want list 1. Just arrow up to that. You'll hit the second key and then whichever list you want, 1, 2, or 3, whatever it happens to be. It's the numbered buttons on there. If you look above number 1, you have list 1 in there. So that's how you can put those in there if they have different lists in there. And then you get to pick what kind of mark you want. If you have a colored calculator, you can pick the color if you like. And then you can hit second and quit to get out of that screen there. All right, so we have the plots turned on. We're going to go in then and let's enter this data in list 1 and list 2. So to enter data, you always hit the stat button. Everything we're going to do is in the stat button, which is right below the delete button. and we're going to edit lists. Right, and you should have list 1 and list 2 showing there. If you don't have a list, if your list is missing, suppose I came up here, don't do this to your calculator, but suppose you didn't have that list there. Suppose it was 1. All right, so you see I don't have a list 2 there. If you go to the top of the list, I want to put list 2 right where this list 3 is sitting. If you hit the second key and the insert button, now it's ready to put a list in there. It wants to know, what do you want to call that list? I'm going to call it list 2. And list 2, if I hit the blue button first, it's in the number 2. And that puts it back in there, because sometimes people delete lists. All right, so once you have that, go ahead and start typing the data in. Time will be list 1, and distance will be in list 2. And then list 2, you can go over there and type those values in. All right, make sure that you have one for each of them.